joy to have had that opportunity to hear your words, Engineer Ilagan.
Ayan, following Ma'am Ira's insightful and meaningful message, please join us in welcoming our distinguished guest speaker who is set to offer her exceptional words that will undoubtedly leave a lasting impression. It sets the perfect tone for the exciting exploration that awaits us. Now, since we boosted our spirits, let us dive na into the heart of today's event.
Yeah, so let's not keep you guys waiting any longer as we embark on this journey of unraveling the transformative power of modern analytical tools. We would like to call on Ms. Kimberly Claire V. Burdeth, overall head of Calibrate 2023, to introduce our speaker for today.
Good morning, good afternoon. So, our speaker for today is an empowered woman who's in pursuit of a career in chemistry, working in the field of science and has profound knowledge in usage of modern tools in laboratory analysis. She graduated Bachelor of Science in Chemistry in the University of the Philippines, Los Baños, Laguna. As she continues to explore this field, she's currently taking a Master of Science in Environment and Natural Resources Management in University of the Philippines, Open University in Laguna. As a professional, she worked as a quality assurance analyst in Asia Brewery Incorporated, Philippines. She became a laboratory chemist in Nanotech Analytical Services and Training Corporation before she became the laboratory section head in the Physical Chemical section in Nanotech Analytical Services and Training Corporation, also known as NASA Labs. Let us all welcome our speaker for today, to widen our knowledge about modern analytical tools and techniques in chemistry, Ms. Angelica P. Buenaventura. Let's give her a round of applause.
Wow, thank you so much for that introduction, Miss Kimberly. Ayan, so good afternoon, future chemical engineers. Good afternoon, Batangas State University. And good afternoon, Engineer Ira. And together with the other engineers present in our event for today. So first of all, I would like to thank you for that wonderful introduction. So nakita ko ulit yung grad pic ko. So medyo refreshing. And thank you so much for inviting us to be with you today in your event for today. So together with NASA Labs, we are very pleased to and honored to be part of your event. And really, we are close to the hearts of the academe, especially students like you, no? So yung mga ganitong event, talagang pinapaunlakan namin as much as possible. So ayan, thank you so much for inviting us. And I would like to commend our hosts for today also. Very energetic. Ayan, so hindi ko alam paano ko papantayan yung energy niyo. Pero yun, please bear with me. And I would like to have a disclaimer na medyo husky lang po yung voice ko, no? Because I have currently a flu. But ayan, so baka mamaya medyo mag-pause na lang po ako just in case ubuhin or something like that. But I will try my best to keep this discussion fun and very interactive with you. Okay? So, before we start, I would like to introduce to you NASA Labs. So kanina nakita na po natin sa profile ko, no, si NASA Labs. So, we are a company of testing laboratory po kami. Ano? So, we are one of the first nanotechnology laboratories na na-establish po here in the Philippines. So, we have two laboratories. First is located in Muntinlupa. So that's our failure analysis and material characterization laboratory. So the second one naman po is here at Cabuyao, Laguna. So this is our water and environmental testing division. So here we conduct water analysis, metal analysis training, and for my talk for today, yun po yung i-discuss ko about water analysis and metal analysis training together with other instrumentation. So, let me share my slide with you. Sorry. Okay lang po bang the host disabled participant screen sharing daw po?
Ma'am, we can present your presentation po. Or
Ano?
kayo na po. Kami na po ang magpe-present. Okay lang po ba?
Sige. Okay lang bang ako na lang para may pointer? Ganun.
O, sige.
Sige. Ayan. Nakapag-lunch na po ba ang lahat? Ayan, share screen. So I hope nakapag-lunch po kayo, kasi itong oras na to medyo nakakaantok siya for most of us. Pero please bear with me. Huwag niyo akong tulugan, guys. Okay? And for the other, ang dami pala natin. 300 plus pala tayo. Ayan. So sana huwag niyo po akong tulugan. Ano po? Yan. Alright. So kita na po ba yung screen? And rinig po ba ako ng lahat?
Yes po, ma'am.
Alright. Sige po, let's start. Okay. So, ayun nga po, na-introduce ko si Nasat Labs kanina sa inyo. So, we do, sa kabilang laboratory, we do failure analysis and material characterization. So, mostly mga semicon and advanced din po yung kanilang mga equipment doon with regards to identification of your elements sa inyong samples, ganyan. So, dito naman more on analytical equipment. Sa kanila more of mga nanotechnology, ganyan. And then dito naman po yung mga analytical instruments po talaga for chemistry dito sa aming Kabuyaw Laboratory. So, ayan po. Let's start with water analysis techniques. So, ito po yung napili kong topic because aside from matututunan po natin dito yung iba't ibang analysis ng pag-analyze ng water, together with this one, hindi po yan ma-analyze ng walang mga modern equipment po. And later on, I will be showing you the development of these instruments from from classical method to modern method, ganyan. So, ayan, ipapakita ko sa inyo yan later. Okay, so let's start. Ayan, so for the objectives of my presentation, first is to present water quality laws. Okay, mabibigla, may laws, pero bibilisan lang natin kasi alam ko namang ayaw niyo yung mga laws, ganyan. And second is to gain understanding on the basic principles of water analysis. Next, to learn different standard methodologies for water testing. And finally, to introduce basic equipment used for water and elemental analysis. So, water quality laws and guidelines in the Philippines. First, kailangan muna nating malaman. Siyempre, hindi lang tayo as scientists, as engineers, hindi lang dapat tayo gawa ng gawa. Hindi lang tayo dapat experiment ng experiment. Dapat alam natin kung bakit, kung para saan natin gagamitin itong certain resources na ito. Hindi pwedeng magsasayang lang tayo ng ating time, effort, and resources kung wala naman palang dahilan. So, we are doing water analysis because we have water quality laws and guidelines in the Philippines. So first of this is the RA 9275. Ito po yung kauna-unahang law for our water body. So this aims to develop economic growth programs in line with the protection of our environment. And ang lead agency po dito is the DENR or Department of Energy and Natural Resources. So here, meron silang tinatawag na wastewater charge system. So have you ever wondered, kapag pupunta kayo sa mga malls, sa mga hotels, or different establishments, saan na pupunta yung mga tubig na na-generate nila? Either sa sink, sa toilet, sa processes ng mga planta, saan na pupunta yon? So any idea, guys? May makakasagot po ba dyan? Wala.
Sa ano po ma'am, wastewater treatment facilities po.
Yes. So every establishment, meron silang mga wastewater treatment facilities. And that's your job as chemical engineers. Yan. Diyan papasok yung job ninyo because some of our TCO or pollution control officers, kailangan engineers sila or yung iba hindi naman. Pero mas maganda kung halimbawa water treatment facility, tas engineer ka kasi alam mo yung mismong process ng pag-treat ng water. So meron akong mga sasabihin words mamaya na i-define ko na ngayon para hindi kayo maguluhan later. Meron tayong tinatawag na influent and effluent. Si influent, ito po yung raw wastewater. So kung ano man yung nilabas niyo sa toilet, nilabas niyo sa sink, that's your wastewater. That's your influent. And then the job of you, the engineers, you will treat it in the treatment plants. Yun nga po, wastewater treatment plants. Iti-treat yan with chemicals, with processes, ganyan. So paglabas niya, ang tawag na sa kanya is effluent. Or minsan yung iba ang tawag effluent. So bahala na lang kayo kung anong gusto nyo, but it's spelled as EFFLUENT. So yan, effluent yung tawag doon. And then, saan napupunta yung mga effluent? Saan napupunta yung after nga ng sinabi ni Sir John Mark? Yan. After nung wastewater treatment plant, saan napupunta na yon? Igagamitin ba ulit nila yon? So, sa atin, meron tayong mga tinatawag na discharge bodies. So, yung mga receiving bodies natin for that water. So, yun yung mga Manila Bay, Laguna de Bay, yan. So, yung ating mga rivers, especially Manila Bay and Laguna Lake, ayan, sila po yung, sa kanila po tinatapon yung mga treated water bodies. Sa ibang bansa, though, hindi pa ganun kasi, syempre, Philippines, hindi pa tayo ganun ka-advance. Sa ibang bansa kasi, nare-regenerate na nila yung tubig in such a way na pwede na nilang inumin. Ganon, after ng mga treatments nila. But us in the Philippines, hindi pa natin kaya yung ganong level. But meron naman ng mga super advanced din ng mga treatments na as in, pag dumadating sa amin yung samples dito as clear as distilled water, kasing ganda ng qualities ng distilled water yung mga pinapadala nilang sample dito. Ano. So yun nga, by that, we will have a wastewater charge system. So lahat ng mga establishment, lahat ng mga malls, yan, ganyan, meron silang tinatawag na wastewater charge system. So every quarter, every month, magpapasa sila ng report regarding the treatment nila ng tubig na nilalabas nila. Of course, di tayo pwedeng magtapon po basta-basta sa mga bodies of water natin like Manila Bay, di ba? Kasi alam na nga natin, polluted na, no? Tapos hindi pa natin mamonitor ng maayos. So, maniwala kayo or hindi, namomonitor po yan ni ENR. Ayan, so nagpapasa ng reports every quarter yung mga establishments just to make sure na yung tinatapon nilang tubig ay malinis po. Okay? So, let's proceed. And they require discharge permit. So, before tayo discharge or magtapon ng tubig, may mga permits po yan. So the lead agencies sa Pilipinas na ano tawag dito, accountable for that is the DENR, Environmental Management Bureau, and kung yung malapit dito sa Region 4, malapit sa Laguna, kasali din po si Laguna Lake Development Authority. Okay? So, however, after 12 years, na-repealed po yun, yung Administrative Order 1990-34. So, nagkaroon naman tayo ng Administrative Order 2016-08. So, this was approved last May 24, 2016 and took effect on June 15, 2016. So, ito naman, ang ginawa lang nila, this aims to create water quality guidelines in classification of water bodies and general effluent standards. Nag-set na po sila ng limits sa ating mga effluent standards. So, halimbawa, may iba't ibang parameters. So, later, papakita ko sa inyo iba't ibang parameters na pwedeng ilagay doon. Wow. pH, dapat ganitong level lang. Nag-set na po sila ng standards. And i-categorize po nila yung water bodies. For example, yung lake, ibang category ito. Yung mga estuaries, ibang category din ito. Yung mga rivers, ibang category din. So, yon. And iba din yung category for yung mga treated waters. Okay? So, hindi ko na i-discuss yan. And ito yung nasa administrative order to. Ito yung iba't ibang parameters, tapos meron sila kanyang classification. May mga ibig sabihin yung mga letters na yan. And ito yung mga maximum allowable limit nila. Yan. However, hindi masyadong nasusunod or hindi mapagtagumpayan ng mga treatment facilities yung baba ng level ng ibang parameters. Kaya mostly bumabagsak pa rin sila. And you know na kapag bumabagsak po yung mga results ng water analysis, may penalty po yan. So parang per day, depende sa parameter, around mga 10,000 per day per parameter. So imagine kung ilang parameter yon, tapos ilang araw, i-charge ni DENR yan sa inyong company or sa inyong establishment hanggang pumasa kayo. So may penalty yon. Kaya po, nagkaroon ng updated water quality guidelines or WQG and general effluent standards for selected parameters. So nagkaroon po ng update dito sa DAW 2021-019. Ito na po yung pinaka-recent updated version ng ating administrative order. So ito po yung kaniyang laman. Tayo. Ayan. So, ayan po yung laman niya. For example, comparison lang po to nung luma at saka yung bago. For example, ito sa ammonia. Dati 0.5 milligrams per liter lang yung kanyang yung maximum allowable limit. Ngayon, 4 milligrams per liter na siya. Medyo naglagay sila ng leeway kasi na mahirap i-achieve. Mahirap siya sa treatment process. And also for the phosphate. Ayan, may mga update lang sila for certain parameters. So, ito yung ginagamit natin ngayon. Okay, so tapusin na natin yung laws. Punta na tayo sa water analysis proper para mas mabuhayan naman kayo. Ano? So this is our basic laboratory operation. Just in case you would opt to be part of laboratory when you graduate. Ayan, kasi open din naman ng laboratories for chemical engineers. So first, we do sampling. So hindi lang naman pupunta, hindi naman pwede na yung i-test natin Laguna Lake, yung buong Laguna Lake i-test na natin, no? So we just, in statistics, di ba? We just have to get a population of your sample. So you would get a portion of your sample, and then meron po tayong mga trained samplers. Kami po dito sa laboratory, meron kami mga trained samplers. Sila po yung kumukuha ng samples sa mga establishments. And then pagdating po dito ng samples, we do sample preservation and sample treatment. So why do we do sample preservation? Kasi po, katulad ng mga pagkain, nai-spoil din po ang tubig. So, napapanis din po yan. So, halimbawa, ngayon, ganito yung value niya for certain parameters, bukas mag-multiply na, and so on and so forth. Kasi napapanis din po yung tubig. So, for the next one, after natin mag-treat yung sample, i-analyze din natin siya. And being engineers and scientists, hindi po tayo matatapos sa sample analysis. Habang buhay na po tayong may math. So, data treatment after that. So, dito papasok yung mga statistics, linear regression. So, i-compute natin yung mga na-analyze natin. And after that, we do reporting. So, kapag na-generalize na namin yung data, kuha na namin lahat, na-collate na namin lahat, we provide reports. And then, yung reports na yun, send namin sa customers. And then, yung customers, isi-send yun ngayon kay DENR. Proving na okay yung kanilang water analysis, kung okay man. Okay, so next, for the collection and preservation of samples. So first, ano bang ibig sabihin ng sampling? Sampling means to collect a portion of material small enough to be transported but large enough for its analytical purposes. So sampling, kagaya nga ng sinabi ko kanina, kukuha ka ng portion ng inyong specific body, and then yun yung i-analyze mo. Of course, wala yung kagandahan ng result natin kung pangit naman yung sampling natin. So sabi dito, result of any testing method cannot be better than the sample which it is performed. So para lang din yung sa thesis ninyo, kung gaano man kaganda yung methodology nyo, kung sa preparation ng sample or sa sampling pa lang, pangit na siya, wala din yan. So ganun kahalaga yung sampling sa ating line of field. Okay? So may dalawang type tayo ng sampling which I will not Sige, i-discuss natin saglit. So, graph sampling and composite sampling. Ito po ay snapshot of sampling area. So, halimbawa, this is the river. Kuha ka single sample collected at a specific spot at a site over a short period of time. Si composite naman, combination lang siya ng graph sampling. Multiple graph sampling at different locations or time. So, yun lang yung difference nila. And also, may iba't iba din tayong sampling container. So, may gumagamit tayong plastics for inorganics, pwede na yan. Ito, ginagamit namin for microbiology. So, bakit glass? Because for microbiology analysis, ini-sterilize po namin to just to make sure na walang contaminants for your analysis. So, dumadaan po sa autoclave. So, imagine kung plastic yan, hindi po pwedeng i-autoclave yan. Okay? So may mga students kung nagpapatest sa amin ng mga thesis nila, medyo mga makukulitis, no? So gusto nilang ipilit. Diba? May dala na silang mga sample dito. So, gusto nilang ipilit na i-accept namin. So medyo specific po kasi kami sa sampling container. Kasi minsan bumabagsak yung results nila, hindi dahil sa sample nila, kundi dahil sa sample container. So yan, better kung halimbawa in the future, malapit pa kayo mag-thesis, right? So kung tawag muna kayo kung ano po ba yung tamang sample container for this analysis, ganyan. Okay, so may iba't iba yan. Which is also mandated in the standard methods for the analysis of wastewater and water. So sample handling requirements, kaya nga sinabi ko kanina na may mga maximum storage period lang po ang ating water because of this. I got this snip from SMEW or the standard methods for the examination of water and wastewater. Parang yun po yung Bible natin for the analysis of water and wastewater. So nandun nakalagay lahat ng parameters and kung ano yung container na dapat mong lagyan, sample size, tapos preservation, kung paano mo siya ipe-preserve, paano mo papahabain yung life niya. However, this is the maximum storage capacity, storage recommendation. Halimbawa si acidity or alkalinity, 24 hours lang silang dapat cool. So within that, dapat ma-analyze mo na siya or else hindi ka na mag-guarantee ng precise na result. Ayan. So ayan lang din yung iba pa. Okay, so let's go through the various environmental parameters and water quality monitoring. So, ito ay mga water analysis proper na po ha. So, along with this, ipapakita ko din po sa inyo yung mga instrument na ginagamit sa pag-analyze nito and its impact on our environment. Bakit natin kailangan i-analyze ito? First, pH. This is the measure of how acidic or basic water is. So, alam ko na, makita niyo ito parate. Nagkaroon na po ba kayo? So this is your analytical chemistry course. Meron po kayong experiment for pH. Nakagamit na po ng pH meter. Yan. So good to hear from you. Sa mga nod nyo, no? Thank you. Ayan. So eto, palagi natin nakikita sa bottled water na binibili natin or for the girls, mga feminine wash, di ba? Dinedetermine yung pH. So ano po ang ibig sabihin ng pH? pH stands for what? Sino po makakasagot po? May plus daw po sa instructor.
Power of hydrogen.
Sino pong nakasagot?
Ako po. John Mark po.
Si John Mark pala. Kaya top 1 na si John Mark. Kanina niyo pa ako sinasagot, guys. Ayan. So, thank you, John Mark. So, pH stands for power of hydrogen. So, bakit power of hydrogen? Because we are measuring the activity of your hydrogen ion. Ayan. And it can be measured using a potentiometric instrument such as pH meter. Ayan po. Ito po yung itsura ng pH meter. Yan. So, bakit natin kailangan mag-measure ng pH sa ating mga water bodies? Because certain aquatic animals cannot live at low pH. So, halimbawa, acidic yung environment, mamamatay, of course, yung ibang isda dyan. And, halimbawa, super alkaline naman, mamamatay din yung ibang aquatic animals dyan. So, it is very important to have your pH regulated or monitored. Next. Ito na pala. Sayang, hindi ko na. Ayan, so next one, I have here temperature. So temperature is the key parameter in checking water quality because pH is dependent with temperature, di ba? So any abnormality in water temperature can disrupt the balance of aquatic ecosystems with devastating effects. So ito naman, wala masyadong, actually yung temperature, pwede nyo din makuha sa pH meter. However, pwede rin kayong gumamit ng thermometer. Ayan. So, bakit natin kailangang i-monitor yung temperature? Because at super high temperature, super init, ganyan. Of course, what would you expect sa ating aquatic animals? Mamamatay din sila. And super lamig naman, mag-freeze sila. So, dapat monitor din natin sila. And color. So, from the word itself, the presence of dissolved natural organic material, usually from aquatic humid matter, causes water to have color. Pag medyo humid yung environment natin, of course, may imagine nyo, di ba, makulay. Medyo magiging madilaw yung tubig. So, bakit kailangan natin i-measure yung color? Because, imagine niyo, you're in the lake. Tapos yung lake niyo super dilaw. Imagine niyo. So, anong significance? Anong ibig sabihin pag super dilaw ng lake ninyo? It means na kapag sumikat yung araw, hindi magpapass through yung sunlight under. Yung mga sun rays, hindi siya magpapass through because block na siya doon pa lang sa matingkad na kulay sa surface. So, paano pag hindi nag-pass through yung ating sunlight or yung sun rays sa ilalim? Some metabolic purposes or processes, I mean, in the aquatic life ay hindi magpo-proceed such as photosynthesis. So, hindi mangyayari yung mga ganon. Kaya kailangan i-measure natin yung color ng water for us to be able to know kung kaya bang mag-photosynthesize ng mga bagay-bagay doon sa ilalim ng water body na yun. Okay, so dito naman, visual comparison. Meron kang set of standards na may specific color units, tapos i-compare mo lang doon yung water or sample mo. Next, chemical oxygen demand. So ito naman is the amount of oxygen required to oxidize soluble and particulate organic matter in water. So COD can be determined by various methods such as closed reflux, digestion, or marami tong methods na pwede. So ito, papakita ko sa inyo, this is a heating block or most commonly known as COD digester. So ganyan siya, yung itsura niya. So ito naman, mga test tubes lang siya or culture tubes. Diyan nyo ilalagay or diyan nyo imimix yung sample with the digestion solution, sulfuric acid. Ilalagay nyo siya dito sa COD meter. Tapos i-digest nyo siya for about 140 degrees Celsius. So sobrang taas niya, no? And then, 2 hours to ha, hindi 1 hour. After 2 hours, i-stand nyo siya hanggang maging room temp. And then, hindi pa natatapos doon. I-read nyo pa siya sa UVB spectrophotometer. So, familiar ba kayo sa UVB spectrophotometer? Ayan, salamat sa mga nod. Yung iba hindi. So, later, ipapakita ko sa inyo. Meron din akong slides for that in our instrumentation part. Okay? Next one. So, si COD, parang kapatid niya to, si BOD. So, yung kanina total oxygen yung na ma-oxidize yung mini-measure natin. Ito naman, biological oxygen demand. Measurement naman to ng amount of dissolved oxygen that is used by aerobic microorganisms. So dito natin malalaman kung meron tayong mga aerobic microorganisms na kumakain ng ating oxygen. So this is very a powerful parameter, especially sa mga planta, sa mga tubig ng mga planta para ma-determine nila kung malinis or hindi yung kanilang water. Of course, kung mataas yung BOD niyan, ibig sabihin maraming microorganisms na naandun kasi maraming kumakain ng dissolved oxygen mo. And kung wala naman, kung malinis naman yung water ninyo, of course, mababa dapat yung BOD level ninyo. So ito yung analysis niya. This is what you call your BOD bottles. Yan. Tapos, ngayon, meron na tayong tinatawag na mga BOD meter. So, ito ay parang pH meter din siya. Doon mo i-read yung dissolved oxygen na makukuha mo. So, may mga computations din siya after. So, ayan. Very modernized na din dahil meters na din yung ginagamit natin ngayon sa pag-analyze ng BOD. Okay, next. Ammonia. So usually just colorless pungent gaseous compounds extremely soluble in water. So, kung familiar kayo dun sa mga nang kidnap, yung nilalagay na something na solution yung towel and then ilalagay dito sa tapos mahihimatay yung tao. Ammonia yon. But I don't know the formulation, wag nyo na ding alamin. Tapos, si ammonia, pwede din siya na panggising sa mga na-faint. Yung parang pinapaamoy nilang ganyan sa mga nahimatay. Yeah. So, but that is the gaseous ammonia, no? So, ito namang ammonia natin, gaseous din siya. So, important din na kuhanin natin yung amount ng ammonia natin sa water natin because it can cause toxicity to aquatic animals and high levels of it can potentially kill aquatic organisms. So, ang ammonia ay madidetermine natin, makukuha natin sa pamamagitan ng paggamit ng ammonia selective electrode method. So, gagamit din tayo ng electrode, parang pH meter lang din siya. Mamaya papakita ko yung itsura. Okay? Next, nitrate. So, ito para lang din siyang si ammonia. So, anong significance? Bakit kailangan natin i-determine si nitrate ng water? Because a high concentration of nitrate together with your phosphorus, nakaka-cause siya ng eutrophication. So, ano po ba yung eutrophication? So, ito po, yung pag meron ka ng excess amount ng nitrogen at phosphorus, magkakaroon ka na po ng eutrophication or magkakaroon na po ng ecological imbalance sa inyong ecosystem causing algal blooms, mga ganon, mga decay and such. So, mga imbalance na to sa inyong ecosystem. So, yun po yung eutrophication. And then, chlorides, another ions na pwede nating ma-measure sa ating ISE or ion selective electrodes. Si chlorides together with the fluorides, mga ions sila, di ba? But of course, they are in the periodic table, nandito sila sa group 7, halogens. So, mostly mga cleaning, mga cleaning tawag dito ions, di ba? Yung fluoride, meron sa toothpaste natin, fluoride, meron sa mga panlinis natin ng CR, mga ganun. So, of course, those ions, yung ibang mga tubig, meron talaga yan naturally. But we have to limit because ayaw naman natin pa-ingest din yung mga drinking water na, mostly sa drinking water to tinitest yung fluoride and fluoride. Of course, ayaw naman natin na too much yung digest natin na ions na ganito. So this is the equipment na gagamitin natin for the analysis of your ions. So iba't ibang electrode lang po yan. So dati kasi mostly type 3 metric pa yung ginagamit. So medyo matrabaho kasi yung titrations and medyo specific siya sa mata ng analyst, depende sa color change. And of course, maraming ways na na-generate. So the advancement ng ating technology, naka-invento na po sila ng mga ganitong electrodes. Ikakabit nyo lang po siya sa meter para ito na yung mismo mag-a-analyze ng ions mo na yon. For example, pH, ammonia, nitrate, chloride, fluoride, cyanide, and so on and so forth. Ayan po. So this is our ion meter na tinatawag. Okay? Okay, next one, phosphorus. So ito naman po, together with nitrate, yung na-discuss ko kanina, in excess amount, magli-lead po sa eutrophication. Kaya importante na i-measure natin siya. So ito naman po, ang marami ding method for this analysis. So usually, stannous chloride method or ascorbic acid reduction method yung ginagamit natin. So magpe-prepare ka ng ganyang reagents, and then babasahin po natin yan using our UV spectrophotometer. Ayan. Next naman, surfactants. Surfactants from the word itself, surf, so bula. So, ba't kailangan natin i-measure yung mga surfactants content ng ating mga tubig? Because, imagine nyo yung mga bula pag pinagsama-sama ninyo, magkakaroon tayo ng shoreline deposits. Of course, pag pinagsama-sama sila, mabablock din nila yung surface, tapos hindi rin makakapasok yung sunlight, and pwedeng mag-adhere din yung ibang contaminants dun sa water. Kaya importante na hindi malaki yung amount ng surfactants in your water. So this is the analysis of your surfactants. Familiar po ba kayo sa glassware? Ano pong tawag sa glassware na ito? Anyone?
Separatory funnel.
Yes po, tama. Separatory funnel. Si Sir Jordan ba yun? Tama ba? Ayan. So, separatory funnel po ang tawag dyan. So, this is used to extract. Kung mayroon kayong dalawang phases na magkaiba, halimbawa, mayroon kayong aqueous phase or organic layer at inorganic layer, yan. Pag-iwalayin nyo sila, gagamit lang kayo ng extracting solvents such as mga chloroform, hexane, ganyan. Dati, gumagamit pa ng DCM, pero ngayon hindi na masyado kasi banned na siya. So, ayan. So, gagamit tayo ng separatory funnel. Super colorful ng analysis ng surfactants. Kaya lang sobrang sakit sa braso kasi nga sobrang daming shaking, sobrang daming extraction. Ayan. Tapos, after extraction, papalabasin ko kasi yung amount ng surfactants mo eh. Ibabasahin mo pa to sa UVBs, spectrophotometer. So, ang dami no? Ang daming analysis na may kinalaman sa UVB. So, later pag-uusapan natin yung UVBs. Another one, oil and grease. So ito, para din surfactants, gumagamit din tayo ng separatory funnel. From the word itself, oil and grease. So of course, kailangan natin siyang ma-extract because imagine po yung content ng fats, oil and grease, pag nagsama-sama po yan at low temperature, pag malamig, di pa natutulog ang mantika. So imagine niyo kapag yung sa mga water bodies, mataas yung oil and grease concentration, tapos biglang lumamig or umulan, tapos nag-change yung temperature, imagine mo makakabuo sila ng mga contaminants, and then magka-clog sila sa mga pipes and tubings, ganyan. So malaking problema. That's also the reason why kapag may oil spill, kailangan tanggalin talaga siya kasi tawag dito, except from the fact na makaka-affect siya sa mga aquatic bodies, delikado rin talaga siya, contaminant para sa mga fishes doon. Ayan, so kailangan natin siyang i-analyze din. Next, total suspended solids. So, ito naman po is particles that are larger than 2 microns found in water column. So as from the word itself, solids talaga siya. For example, may tubig ka, tapos sinake mo, may makita kang mga solids na suspended, yun po yun. So kailangan din natin siyang i-measure kasi yung mas malalaking particles, pwede silang mag-clump together, mag-adhere together, causing contaminants din and of course blockage din sa ating mga tubings or pipings. So ito yung analysis ng TSS. Usually gravimetric method to. So what's this setup? What do you call this setup, guys? So anyone? So this is called filtration setup. So ito ay Buchner funnel. Tapos meron kang air suction dito. Ayan. Either vacuum. Imagine niyo may vacuum dito, may air suction. Papasok niyo dito, ilalaglag niyo dito yung water niyo. Tapos may filter paper kayo dyan. Tapos, edi magba-vacuum siya dyan. Tapos yung filtrate, nandito yan, yung water niyo. Tapos maiiwan dito yung total suspended solids niyo. Nasa filter nyo. Nasa filter paper. Tapos i-weigh oven nyo yan para ma-dry. Tapos i-weigh. Pag na-weigh nyo na, kung ilan yung amount nun, yun yung i-compute nyo. Yun yung mismo total suspended solids na laman niya. Ayan. Okay? Next naman, total and fecal coliform. Ayan. So total and fecal coliform, ayan yung makikita nyo dito. Ayan. Ano yan? Total coliform bacteria are commonly found in the environment and are generally harmless. However, fecal coliform bacteria are a subgroup of total coliform bacteria. So usually, nagpapatest po sila niyan because ayaw naman natin yung tubig natin ay may bacteria, di ba? So, the presence, paano pag nagpatest po kayo ng total and fecal coliform, tapos nag-positive siya sa fecal coliform, ano pong ibig sabihin nun? Ang ibig sabihin po nun, the presence of fecal coliform in a drinking water sample often indicates recent fecal contamination, meaning that there is a greater risk that pathogens are present than if only total coliform bacteria is detected. Sabihin, pag nag-positive po yan sa fecal coliform, may presence of poop. Ayan, may contamination ng poop yan. So we have a previous company na siniserve. Actually, hanggang ngayon, customer namin sila. So, ang problem nila is, meron silang violation. So, hindi pa pangalanan yung company na. Meron silang violation kay LNDA because bagsak lagi yung kanila coliform. So, fecal and total coliform nila bagsak. So, meron silang penalty lagi kay LLDA. So, pinapatest nila dito, hindi sila tumigil hanggat makuha nila yung tamang timpla sa kanilang treatment facility na kung saan mawawala yung presence ng mga fecal and total coliform. So kasi nakukuha ito minsan, halimbawa sa mga planta, meron silang mga tangke, di ba? Tapos minsan yung mga tangke open. And of course, may mga ibon dyan palipad-lipad, tapos magpupok, eh di makukontaminate na agad yung water nila, may presence na sila agad ng fecal coliform. So yung mga ganon, makaka-apekto kasi sa buong process ng planta ninyo. Imagine, yung source mo ng tubig na dediretso sa planta is contaminated, eh ang bacteria, exponentially growing yan. So baka ngayon, ilang ano pa lang yan, ilang culture pa lang yung nandito, pero mamaya mag-multiply na yan sa mga susunod na processes. That's why it's very important to test the total and fecal coliform. Okay? All right. Ayan, so we are done with the water analysis. So now let's proceed with instrumental analysis. Ayan, so first, meron akong dalawang i-discuss sa inyong instruments. Of course, marami kasi talaga tayong various modern analytical equipment na ginagamit na sa laboratory. But I will be focusing on this two since ito yung mostly ginagamit talaga. And then mostly lahat ng laboratories merong ganito. First is UVVs and second is the atomic absorption spectrophotometer. So let's define spectroscopy first. Yan. Familiar ba kayo sa word? So this is our electromagnetic spectrum. So spectroscopy, from the word itself, is the study, spectroscopy, is the study of interaction between light and matter. So ayan po yung ating electromagnetic spectrum. Yung interaction po ng radiation sa ating electromagnetic spectrum, yan po yung ating na-measure po using ating UVs. Ayan, ito yung ating electromagnetic spectrum po. So makikita natin dito, anong sabi natin sa ating sa ating analytical chemistry class as the wavelength. Kapag mas maliit yung kapag mas mahaba yung wavelength, anong nangyayari? Kapag mas mataas na wavelength, mas mababa ang kanyang frequency, di ba? Tama? Inversely proportional sila, wavelength and your energy. Ayan. So this is your gamma, soft X-rays, hard X-ray, ultraviolet, and itong maliit na portion na to, that's your visible ray. So ito, visible to ultraviolet, yan, yung nami-measure natin using your UV visible spectrophotometer. And ito naman yung mga radio waves. So, ayan, yung kaniyang, asa na ba yun? Yan, ito yung hertz niya, yung 10 to the 2, 10 to the 3. Kaya kung mapapansin ninyo, ito yung mga radio waves. Ayan, ang mga sources niya, yung mga AM radio, FM radio. So, kaya kung makikita ninyo, yung mga pangalan ng radio station natin is mga 101.9, mga ganon. Kasi yun yung hertz nila. So, yun yung mismong hertz nila. Kasi 10 to the first, 10 to the second. Kaya ganun yung pangalan ng mga nila. Mga 90.7, love radio, mga ganun. Depende yun sa hertz. So, yun yung nababasa nila, frequency. Okay. So, huwag na natin yung pag-usapan. Ayan. So, ito naman, spectroscopic, ito ay iba't ibang phenomenon na ng interaction ng light at ng matter. Okay? So, pag-usapan natin isa-isa tong mga to. First, meron tayong absorption. So, interactions lang po ito ng light versus matter. Okay? Ang absorption po, this is a process by which a light is absorbed and converted into energy, and it depends on the electromagnetic frequency of light and the object's nature of atom. So, absorption of light is directly proportional to frequency. Absorption. Why does your solution appears to be color blue? Because it absorbs electromagnetic radiation around 650 nanometers dito banda. So, yung complementary niyan, it would appear color blue. So, ganun siya. So, pabaliktad lang siya. So, ganun lang kung bakit nag-a-appear yung certain colors natin. That's because of the wavelength na complementary sa kanya. Okay? Next one naman, fluorescence. So, it is the emission of light by a substance that has absorbed light or other electromagnetic radiation. So, si fluorescence po, para din siyang C absorption. So, imagine you have your solution at ground state. Okay, ano tayo dito ha? Imagine ninyo, ano tayo ngayon? Atomic level. Ayan. Atomic level muna tayo. So, nasa ground state tayo, and then when we are heated by a certain energy, such for example, light. Kapag tayo, ito yung atom mo, na-hit siya ng certain energy, of course, anong tendency mo? Pupunta ka ngayon or magja-jump siya sa excited state. Ayan, yung excited state natin. So that's your absorption, yung na-discuss natin kanina. That's your absorption, yung pagpunta niya from ground state to excited state. But this excited state, this is not a stable state. So ayaw ni electrons dyan. Kasi unstable po yan. So ang gagawin niya, mag-e-emit siya ng light, babalik siya dun sa ground state. Babalik siya dun sa ground state, and there are certain atoms na kapag bumalik siya, nag-e-emit siya ng light, nag-e-emit sila ng other forms of energy. So that's what you call fluorescence or emission. Ayan. Excuse me. So phosphorescence naman po, this is a type of photoluminescence related to fluorescence. So under ito ni fluorescence, pero ang kinaibahan lang nila, etong material na to, this does not immediately re-emit the radiation it absorbs. So di ba kung kanina, nagre-re-emit niya agad. Pag bumalik siya sa ground state, nag-e-emit agad siya. This one, medyo mas mabagal yung pag-emit niya. So this time, the slower time scales of the emissions are associated with forbidden energy state transitions. So this is, mas madidiscuss ko sa inyong quantum mechanics. Medyo mas, medyo advanced na po siya. Pero ito yung tinatawag na forbidden energy state. So, during your phosphorescence, mas mabagal yung emissions due to forbidden energy states. Ayan. And next one, ito, ang ganda niyang tignan, di ba? Chemiluminescence. Under pa rin po ito ng fluorescence. So this is the emission of light as a result of chemical reaction. So marami na po tayong analytical techniques na ginagawa recently, na gumagamit ng chemiluminescence. So usually gumagamit tayo ng UV light and ng chemicals na nagaganyan, ang tawag dyan? Nagluluminescence, yan, nagpo-fluoresce or may capability to do this thing. Naggamit tayo ng mga chemicals na ganyan, itatapat natin sa UV para makita natin yung reaction. So, actually, yung recent natin na Nobel Prize, familiar ba kayo doon sa quantum dots? Yan. So, mga nagpo-fluoresce din sila, ganyan din yung itsura noon. And ayan. So, dito naman sa laboratory namin, ginagamit din namin ito for the testing of our E. coli. So, nade-determine namin yung presence or absence ng E. coli. May nilalagay lang kaming broth, may nilalagay lang kaming media, tapos kapag tinapatan namin siya ng UV light, nagpo-fluoresce siya. Ayan, so makikita namin may presence or absence ng E. coli. Yan. So, meron ng mga modern analytical equipments na pinagsasama-sama yung chemiluminescence, phosphorescence, and fluorescence in one unit para mas maging maganda or mas maging mapabilis or efficient yung analysis ng mga chemicals or electrons na may capability for this phenomenon. Next, scattering. It is a general physical process where some forms of radiation, such as light, sound, or moving particles, are forced to deviate from a straight trajectory by one or more paths due to localized non-uniformities in the medium through which they pass. Ang hirap nung So in layman's term, ganito. Ang scattering, imagine you have your solution. Meron kang, for example, this one, meron kang mga solutions dyan. Imagine na may mga particles sila. So, yung mga particles, due to Brownian movement, di ba parang may tendency silang maging random sa pag-move. So, may mga particles sila. And kapag na-hit sila ng light, of course, yung light mag-i-scatter. Halimbawa, ito yung particles, tapos na-hit ng light. ang tendency ng light, gaganon, di ba? Mag-i-scatter yung light. So, through scattering, mami-measure natin yung amount ng light na scatter. So, yon. Ang mga ginagamitan ng ganito is, first na equipment is turbidity meter. So, kung familiar kayo, mami-measure niya yung pagka-turbid ng inyong solution. Magbibigay siya na turbidity measurement. Tapos, ang unit niya is NTU. Okay? Next one naman is the particle size analysis. Also, yung laser diffraction method. Meron din tayo dito sa laboratory nun, yung particle size analyzer. So, i-determine nun yung particle size distribution ng inyong solution. Ayan. So, yun yung mga analytical equipment na gumagamit ng scattering as their phenomenon. Emission naman po, this is a process by which a higher energy quantum mechanical state or particle becomes converted to a lower one through the emission of photon, resulting in production of light. So ito, may kanya, ang bawat elements natin, may characteristic emission lines po yan. Halimbawa, sa hydrogen, ito yung kanyang mga emission lines. Si helium, ito yung mga emission lines. Si lithium, yan. May kanya-kanya yan sila, characteristic to that specific element. So, ayan. Ang mga equipment na gumagamit ng emission as their phenomena is inductively coupled plasma, optical emission, spectrophotometer. So meron din tayong atomic emission spectrophotometer. So yan, mga emission yung ginagamit nila sa pagdetect ng mga metals. So balik tayo dito sa electromagnetic radiation. This is a form of energy whose behavior is described by properties of both wave and particles. So kung makikita natin itong visible light, dito po maglalaro yung ating UV up to visible measurement. Ayan. So absorption naman, yung phenomena na gagamitin natin for the UV spectrophotometry. So ang dami kong diniscuss na na phenomenon, interaction ng light and matter. Pero kay UVB, si absorption lamang po yung kanyang phenomenon na ginagamit. So this is when light passes through an object. The object will absorb certain of the wavelengths, leaving the unabsorbed wavelengths to be transmitted. So, excuse me. This residual transmitted wavelengths will be seen as color, and the absorption can be detected by suitable detectors. So, si UV spectrophotometer po, for those na hindi nakakaalam, this is an instrument used for measuring the transmittance or absorbance of a sample as a function of wavelength. So, a measurement po ito ng attenuation of beam of light after it passes through a sample or after reflection from a sample surface. So, ito po yung itsura niya. Ay, saan na ba? Ayan. Sabi niya, how do we measure absorption of light? So, we have two optical systems. First is the single beam optical system. So, maybe when you go into higher chemistry subjects ng inyong course, no, kapag-gamitin din kayo ng UVBs, or during your thesis days, baka gamitin nyo din itong UVB. So this is important na alam ninyo yung different optical paths na meron tayo for UVBs. First, we have single beam. So single beam, we have here a light source. Ito yung block diagram lang po ng ating instrument. Going through the monochromator. So si light source, this is also your radiation source. And then we have here your wavelength selector or monochromator. So the purpose of your monochromator, it selects a broad range of your, from the broad range of your light, isa-select niya kung ano lang yung kailangan niya na wavelength. For example, ang analysis mo lang, iron analysis lang. So at certain wavelength lang yun, mga 280, ganyan. Si monochromator, ang job niya is to select only the 280 nanometers from the broad spectrum na ipinakita ko sa inyo kanina. And then this is your sample folder going to your light detector. So ayan, yung P naught, ito yung light na magpapass through sa sample nyo. And then yung P, ito naman yung nag-pass through na, yung na-absorb na light going to your light detector. So si detector, kukuhain niya lahat ng pulse signals. And then, lahat ng pulse signals na yan, i-collect niya, magkakaroon siya sa loob ng mga mathematical integrations and such, para ang makikita na lang natin is absorbance, transmittance, or concentration sa ating computer or sa ating readout system. Okay, the next optical system na kaya ni UV spectrophotometer is this one. This is the modern part. So, ito yung kagandahan yan. Pwede natin ma-differentiate yung mga ginagamit before sa ngayon. So, when I was in college, ang UVs pa namin noon ay dihigit pa. So, kailangan mo pa iganon para ma-measure mo yung absorbance or transmittance or yung concentration na kailangan mo. But nowadays, I am amazed sa mga nakikita kong UV spectrophotometer because with just one click, makaka-measure na siya ng madaming standards, madaming samples, may auto-samplers na and so on and so forth. Sobrang ganda na ng advancement ng technology with the span of how many years lang. Excuse me? So this one naman is the double beam spectrophotometer. So makikita natin kanina, straight path lang ito. Ito naman, dalawa siya. So pareha pa rin, may light source, may monochromator. However, dalawa yung sample holder mo. Yung isa for your sample, yung isa for your reference. So this one, automatically, i-correct niyo na yung absorbance from your reference to your samples before siya pumapunta sa detector. Kasi sa single beam, isa-isa mong ilalagay yon. So ilagay mo yung sample mo ng blank, measure mo yung absorbance, lagay mo yung sample mo ng standard, measure mo yung absorbance, and then i-minus mo yun, i-compute mo. Tapos lagay mo ulit yung blank, lagay mo ulit yung sample mo, ganun. Paulit-ulit ka. So this one, automatically niya nang namaminus. So that's the advantage of it. So di ka na kailangan every now and then mag-minus, maglagay, ganon. Kasi before pa siya makapunta sa detector, nasusubtract niya na yan dito. Yan. Going to your amplifier, going to your readout display. So this is an example of UV-Vis. We have here Hitachi UH5300, double beam spectrophotometer na yan siya. So ganyan yung itsura ng UV-Vis spectrophotometer natin. And mind you, this one is one of the tawag dito, high-end UV-Vis spectrophotometer kasi pwede siyang gumamit ng tablet as its readout system. So, pwede siyang gumamit ng MacBook, ganyan. Any iOS device. So, pwede natin siyang magamit kahit wala ka dun sa mismong UV-Vis mo. So, makakontrol mo siya. Ayan. So, usually, ito yung light source. Di ba pinakita ko sa inyo yung block diagram ng UV-Vis kanina? So, pwede tayong gumamit ng deuterium or hydrogen lamps kapag yung measurement mo is 400 to 200 nanometers. Tungsten naman pag ito medyo mas broad siya. However, ang nangyayari kasi, previously, ito pa lang yung merong develop sa ating technology. Itong dalawa pa lang na to. However, mostly ng mga manufacturing industries or academe, ang problema po nila is mabilis mabust yung mga lamp na ito. So yung mga lamp natin, para lang bumbilya din yan sa ating bahay na may certain number of hours lang silang buhay. So napupundi din po sila. So this one, deuterium lamps, around parang 350 hours lang yung capability niya. Ito 1,000 hours lang. So parang every year, kailangan magpalit ng mga manufacturing industries. So ang nangyari po, si ating mga scientists, nag-develop sila ng lamp kung saan makaka-iwas na sila sa ganon, sa mga papalit-palit lagi ng lamp. So merong na-develop which is the xenon flash lamps na kung saan kaya naman din niya yung mga wavelength na kaya nitong dalawa, 190 to 190 to 1,100 nanometers, yung kaya niyang wavelength, and it has longer shelf life. So, ang xenon flash lamps, ang guarantee niya is 5 to 7 years. So, imagine, ang ganda ng development. So, dito, nagtatagal na yung lamp mo and less costly ka pa. So, kasi dito, pwede ka magpalit every year. Okay? Ito naman yung wavelength selector, yung sinabi ko sa inyo kanina, yung monochromator, yung nagsaselect na wavelength na kailangan nyo. Diyan. And then, of course, your sample cell. So, in the future, pwede kayong humawak nito. This is very mahal. So, parang I think yung isang ganyan is parang 5K. Depende pa siya sa kung anong material na ginamit doon. So, this is your sample cell holder. Dito ilalagay yung sample ninyo for UV-Vis analysis. So, nag-iiba-iba po yung size niyan. Depende po sa application ninyo. So gagamit tayo ng glass cuvette for visible light only. Quartz naman for both visible and ultraviolet light. But quartz is relatively more expensive. Siyempre, quartz yan. Around mga parang 8K yata per isang ganito. So pag nakabasag ka talaga sa first mark mo, yung unang sahod mo, dyan mo lang talagang mailalaan. So mag-ingat kayo kapag pinahawa kayo yan in the future. We also have plastic cuvettes. Kaso ito naman is disposable. So medyo yung mga application nito siguro mga food, mga makukulay na mga solutions, yung pwede nyo nang itapon after. Pero of course, this is not relatively environmental friendly. Ayan. So, the reason bakit iba-iba yung sample cell, ay may reason yan. It's because, for example, gagamit ka ng glass cuvette for UV region. Eh, alam naman natin na ang glass, nag-absorb siya ng UV light, di ba? So, hindi pwede yan sa UV region. Dapat ang UV region mo, quartz cuvette ka talaga dapat. Ganyan. Okay? So, another advancement po sa ating technology, ito po is yung 6-cell turret. So, ito po yung loob ng UV visible spectrophotometer. Naturally, isa lang po yung sample holder niyan. So, imagine nyo na wala tong bilog na to. Dati po, isa lang po talaga yan. Yun yung single beam. Imagine nyo po, are you with me? So, dati, isa lang po ito. Itong square na to, yung binibilugan ko po, yan lang mag-isa yan. So, sa single beam, isa lang yan. Ngayon, na-develop naman si double beam. Dalawa na sila, times 2. Isa dyan, isa dito. And the recent development naman po is ito, the 6-cell turret. So, ano pong ibig sabihin yan? Meron kang for your reference, double beam din po ito. This is for your black, and this is for your standards. Tapos, pwede rin siyang samples. With just one click, iikot na po yan mag-isa. Tuloy-tuloy niya na pong babasahin yung standards and samples ninyo. So, see the advancement. Sobrang ako na amaze talaga ako. Lalo na pag na-experience mo or nakita mo yung pinakaunang version going to the most advanced. And meron pang tinatawag na, meron pa tayong mga available na auto-samplers. So, yun, sinisip lang talaga niya sunod-sunod. Yan. And detectors, ito yung mga nag-produce ng electrical signal. Signal processors and readout system, ito naman po is yung parang computer nyo lang naman. Kung saan para makita ninyo yung results. Yan. Familiar po ba sa Beer-Lambert's law? Sino po makakapag-dictate sa akin ng Beer-Lambert's law? Kung familiar po sila. Alam niyo po ba to? Anong pag-aralan na po ba to? Wala, hindi na pag-aralan po sa analytical chemistry. Wala, sige, discuss. Papahapyawan na lang natin kung hindi nyo pa na-discuss. Ito yung law na na ginagamit sa UV spectrophotometer. So, ito lang naman yan. Ang ibig sabihin lang yan, ang absorbance daw ng inyong solution ay equal sa yung E, ito ay molar absorptivity. B, ito yung concentration of your sample. I mean, path length pala yung B. And C, that's your concentration of your sample. So, yan lang naman yung ibig sabihin no? Lambert's law. So, tandaan nyo yan. So, mga chem majors dapat kabisado to. Marami kayong equations na ide-derive in the future years ninyo using this formula. Ayan. Okay? So, ito naman yung mga functions ng UV-Vis. First, pwede kang kumuha ng wavelength scan. So, for example, you have, ito mga thesis students nagpapagawa ng ganito dito. For example, you have your solution at hindi mo alam yung maximum absorption niya. Pwede mong iparun yung wavelength scan ng solution mo. Ayan. Tapos ito po yung makukuha natin. Makakuha tayo ng parang spectra. Hindi siya parang. Spectra talaga siya. Kung saan ilalabas niya kung ano yung maximum absorption. Ito yon, yung peak na yon. Ibig sabihin, dyan yung maximum na mag-absorb yung inyong solution. Sa, bawa ito, 350 o mga 400 nanometers. Another one, kaya niya yung calibration or concentration determination. So, si UVBs, pwede kang gumawa ng calibration curve and makukuha mo yung concentration ng unknown mo. So, paano ba nangyayari yon? So, for example, ginagamit natin yung calibration curve. Familiar po ba kayo sa term na calibration curve? Hindi pa din? Ayan. So, ang calibration curve po, set of standards. Yan. Halimbawa, magpe-prepare ako ng, excuse me, magpe-prepare ako ng series of standards, and then, kukuhain ko yung absorbance niya, tapos ipa-plot yan siya ni UV-Vis. Sa ating statistics, ang magandang R squared or correlation coefficient is near 1. Siguro alam niyo na po ito, no? Ang magandang R squared ay near 1 dapat. So ito, this is a real-time analysis po namin ito dito ha. So ako po ang nag-analyze niyan. Detection of hexavalent chromium po ito sa ating, dito sa laboratory namin. So nakuha ko pong R squared ay 1 dahil maganda talaga yung ating UVVs. Ayan, so nag-prepare ako ng series of standards, ni-run ko yung absorbance niya sa UVVs para makakuha ng calibration curve. And then I have my unknown samples. So ano mangyayari pag meron akong unknown, i-read ko yung samples na yon ng unknown, hindi ko alam yung concentration nun. May ilalabas si UVVs na absorbance. So this is absorbance versus concentration. May ilalabas si UVVs na absorbance ng certain solution na yon. For example, dito. Dito yung absorbance niya, 0.50. Ngayon, ang gagawin ni equipment natin, gagawin ni UVVis, i-interpolate niyan dito sa calibration curve mo. Halimbawa, dito banda yung absorbance na nakuha ko, i-interpolate niyan sa calibration curve mo para ang ibigay niya sa yung result ay around here. So, may mangyayari interpolation. Around 0.25 yung sasabihin niyang concentration ng aking unknown. So, ayun lang po. Interpolation yung tawag doon. Kaya kailangan natin ng calibration curve pag mag-analyze tayo. Ayan. So for example, ito yung ating curve. Tapos andito yung ating absorbance. Interpolate niya doon sa inyong calibration curve. Ayan, sorry. So, applications po ng UV-Vis spectrophotometer natin, pwede siya for DNA and RNA analysis. Ayan. Pwede din siya for pharmaceutical industry. So marami po development ng biopharmaceuticals na ginagamitan ng UV-Vis spectrophotometer. And actually, meron kami mga thesis students na from De La Salle yata to. Nag-synthesize sila ng sulfamethoxazole. So it's an antimicrobial drug. Tapos, pinaka-characterize nila sa amin. So, ito yung spectra, no? Ni-run ko siya sa wavelength scan. And sabi niya, ang acceptance daw nila is from 280 to 300, yung acceptable na maximum absorption. So, ang nakuha niya is 290. So, tama yung synthesis nila kasi pasok sa characterization. So, yun, nakagraduate na sila. So, ayan. Ito yung mismong spectra nila. So, yan. I just took a snip of it. So, yan. So, ganun din kayo, ha? Galingan niyo yung mga thesis niyo para gagraduate na din kayo. Tapos, pwede rin siya for bacterial culture. Ayan. Beverage analysis. Ayan. Sa caffeine naman ito. And yun. Tapos na tayo sa UVVs. Punta na tayo sa AAS. Ayan. So, mabilis na lang to, guys. So, this is our elemental analysis. Pwede silang ma-determine into two, qualitative and quantitative. So, for the elemental analysis, meron tayong classical at saka modern methods na tinatawag. So, yung classical methods, ito yung mga gravimetric, volumetric, colorimetric, ayan yan. So, yung mga gravimetric, yung katulad ng pinakita ko kanina, yung mag-filter, i-weigh, i-oven, and such. Volumetric, titration siya. Familiar ba kayo sa setup na to? Nakapag-titrate na po ba kayo? Ayan, di ba? Isang drop, over-titrate agad. Overrun. Nakapag-overrun na ba kayo? So, yan. Or naabutan niyo kayong pandemic? Ay, hindi yata. Kasi yung iba, meron kaming mga OJT na simulation daw yung gamit nila sa mga experiments. So pag nagtatitrate sila, pinipindot lang nila yung screen and then ganon. So mas maganda na na-experience nyo din siya na personally. Ayan. So ito yung classical method, volumetric titration. However, ngayon, may mga modern methods na may auto-titrators na tayo na kung saan siselect mo na lang, tapos siya na mismo yung magta-titrate dun sa solution ninyo. So modern methods naman ng mga elemental analysis is this one, X-ray fluorescence, inductively coupled plasma optical emission spectrophotometry, AAS or atomic absorption spectrophotometry, and etc. So madami ng modern methods na determined during the 20th century. So this one, na-develop siya para mas padaliin yung buhay natin and also to be able to have a greener chemistry. Kasi nga minsan yung mga classical methods, ang daming ways na nag-generate and minsan gumagamit pa sila ng mga hazardous chemicals for their detection. Kaya modern methods, ito, mas ano siya, minsan yung iba direct analysis, like XRF, ganyan. So now we are gonna focus with atomic absorption spectrophotometry. So kagaya ng na-absorb ko kanina, kagaya ng na-discuss ko kanina, sorry, medyo nasasabaw na tayo. So bibilisin na natin, no? Medyo bored na ata kayo. Kagaya na na-discuss ko kanina, basic principle lang po nito ng AAS natin is that ang inyong solution na nasa ground state, of course, kapag na-hit ng isang energy, aakyat po yan sa excited state. Ano po? And that's your absorbed energy. So ito po yung dinedetermine. Ito po yung kinukuha sa AAS. Since alam naman natin na itong absorbed energy na ito, the intensity of the absorbed light is proportional to the concentration of that element. Okay? So ito po yung ating itsura ng AAS. Ayan. So, meron tayong tatlong types. Ito medyo specific sa amin. Ayan, meron tayong tinatawag na flame AAS. Gumagamit tayo ng flame. Meron din graphite AAS. Gumagamit naman ng graphite. And meron din naman mga AAS na gumagamit ng tandem or meron na siyang flame and graphite at the same time. So, ito ay schematic diagram lang na nangyayari sa loob ng AAS. So, ito ay ginagamit sa pag-detect ng mga metals po, ha? Huwag kayong malilito. Ito ay metals. Halimbawa, meron kayong cadmium content, gusto nyo ma-analyze, pwede nyo gamitin ng AAS. Lead content, yan, pwede nyo din niyang magamit. Okay. So, this is your sample. For example, yan. Tapos po, meron ng zipper. And then, ito po ay ginagamitan ng air at fuel. So, may compressor and meron din tayong fuel which is acetylene ang ginagamit natin dito. So, meron ding mga ibang elements na kailangan nila argon gas, kailangan nila nitrous oxide, iba-iba po, depende sa element na kailangan. And then, pag na-sip na po yung sample, pupunta po yan sa flame. So, ano mangyayari pag nagka-flame? Yung inyong sample in solution, ma-atomize. So, mag-spread out yung atoms nyo, no? Yung na-atomize na sample nyo na yon, mahihit ng light from the hollow cathode lamp, ayan, tapos going through your monochromator, detector, amplifier, and your computer. So, ganun lang din po yan. Ito po yung itsura ng monitoring screen ng AAS po natin, ayan. Ito yung mga atomization profile niya, nandito yung series of standards and samples, and dito naman yung calibration curve. Ayan. So, for example, this is your sample analysis ng iron. Ito yung calibration curve mo. Ito yung atomization profile mo ng 0, 1, 2, and 4 milligrams per liter. Zinc, ito naman yung example niya. Ayun. So, that's the end of my slide, I think. So, yun. Si atomic absorption spectrophotometer, ginagamit siya sa pag-determine ng elemental content. Pero pa-isa-isa lang siya. That's our, so far yun yung kaya niya. But we have another equipment, yung inductively coupled plasma optical emission spectrophotometer. Yun naman po is, halimbawa, meron kayong kailangan 10 metals. So, kaya niyang i-detect yung 10 metals simultaneously. So, medyo mas advanced siya. So, kaya na i-detect ng sabay-sabay yun with just one click. I-determine niya or ilalabas ko sa inyo yung lahat ng concentration ng mga metals na yun. So that's a little bit more advanced than AAS. Pero depende pa rin sa application na kailangan niyo. Ayan. So this will be my references. And that's the end of my presentation. If you have questions, pwede po. The floor is open for your questions po. Thank you.
Ayan, thank you po, Miss Aika, for that wonderful presentation. Tunay nga namang napakaganda ngayon ng evolution ng ating technology. Yun nga, from classical into yung more modern na, di ba, partner?
Tama, partner. Kagaya nga ng sinabi ni Miss Angelica kanina, dati yung kanila dihila lang. Ngayon, meron ng nag-o-automatic na mamaminus bago mapunta dun sa detector. Grabe naman talaga ang naging advances na natin sa technology and mga tools na ginagamit nga for chemistry. So, ayun.
Yes. Tama. And I hope gising pa kayong lahat. Gising pa ba kayo? Heart react
Gising
nga
pa.
dyan.
Heart react naman sa everyone. Nagising pa.
Ayan.
Ay, nako. Hindi yan.
Ayan.
Ayan.
Sana nag-e-enjoy pa rin kayo. Pero before we proceed any further, I would like to take a moment to invite your question for our esteemed speaker.
And of course, while you formulate your thoughts and questions about the talk, about the webinar, let's take a moment to express our gratitude, of course, to Ms. Angelica Benaventura for taking her time to share her expertise and dedication, making today's session incredibly enlightening.
Ayan, so we will be moving for our open forum session. We still encourage live questions through the raise hand feature. We have collated pre-prepared questions to ensure a comprehensive discussion. Your engagement is what makes our session dynamic and informative.
Ayan, so for the first question, for the first pre-prepared question that we have, exploring the impact of modern analytical technologies, what emergent trends or paradigm shift have been observed in the utilization of advanced analytical techniques within the analytical chemistry community.
Ayan. So every question, sasagutin ko na, no? Tama po.
Apa.
Parang ano to, parang Miss Universe. Tama, kakatapos ng Miss U natin. So thank you for that wonderful question, Sharon. And sige, pasimplihan lang natin. No? So sabi dito, what emergent trends or paradigm shifts? So first of all, depende po talaga siya sa takbo ng panahon. So, as I have mentioned earlier, may mga ginagawa kasi tayo before na sobrang hihirap, ganyan. And then, as time goes by, marirealize ng science community na pwede pa rin natin itong padaliin, ganyan. So, or mas may greener way, or mas may safer way. So, I think yung mga ganon, first is health issues. Pangalawa is yung environmental or economic importance nung yung mga pwedeng maging paradigm shifts dyan. First, yung sa health na masasabi ko because as we can see or kung alam niyo, familiar ba kayo sa pipettes? Yung ginagamit natin pang di ba gumagamit tayo ng aspirator doon? Para masip. Gusto niyo ba ng example? Ay, wait lang. Sige. Di ba may aspirator tayo? Ay, meron tayong pipette. Tapos may aspirator. Sige, kukuha ako para mas maganda yung logic. Yeah, I'm back. So I obtained a volumetric pipette. So ito. Ayan. Medyo mahaba siya. Pipette siya. So I think nakagamit na kayo nito, no? Since nag-analytical chemistry na kayo. Gagamitan natin dito ng aspirator, right? Para isip. Tama? So in the previous years, So pinakita ko lang para may imagination, ganun. So in the previous years, ang ginagamit ng scientists is mouth. Imagine, bibig po ang ginagamit ng scientists to sip the solution. So either toxic man yan or bacteriological samples, mouth ang ginagamit nila. So imagine that. So I think yung mga shifts na kapag-affect dyan is yung health nila. Siguro na-realize nila na sooner or later, parang may nai-inhale na kaming mga acid, parang may nai-inhale na kaming mga solvents, ganyan. So first, yun yung magli-lead sa kanila for improvement. Kaya ngayon, hindi na nila ginagamit yung mouth. Ang ginagamit na nila is aspirators and recently, may mga tinatawag na tayong micropipetors. Hindi na rin kayo gagamit ng aspirators, kundi fingertips na lang para i-control yung bulb, ganyan. Para ma-transfer from one to second glassware, no, ganon. So another one naman is yung cost natin sa waste, yung effect nito sa ating environment. So imagine, meron tayong mga analysis na gumagamit pa ng mga yung halimbawa sa titration, meron tayong mga analysis na gumagamit ng dichromate as its titrant, ganyan. So imagine the waste na nagagamit natin. To mention, ang chromium ay super ano siya, one of the hazardous chemicals talaga siya. Very toxic. Not only sa ating health, but also to the environment. So imagine kung napakaraming waste na ma-generate mo niyan, kawawa naman si Mother Nature. So yung mga scientists, nagde-develop din sila ng mga paraan to advance their technologies for the enhancement and for the betterment of our environment. Ayan. So those are the parang mga impacts or trends na pwedeng mangyari or maka-affect para ma-develop yung ating mga analytical techniques.
Ayun, thank you po. For susunod naman pong question natin, mag-entertain naman po kami ng audience po natin. Paki-raise hand na lang po para magtanong. Yes, Janzel. Naka-mute ka, Janzel.
Ayun, okay na po ba?
Yes po.
Ayun, hello po and good afternoon, Ma'am Aika. Ang akin pong question ay nakapokus po dun sa kung bakit po gumagamit ng AAS ngayon. As we all know po, tayo po ay nagpo-push through ngayon sa paradigm shift sa paggamit from chemical processes to use na ginagamit po ngayon to biological processes as as a key to push through conservation and innovation at the same time. Ang akin pong question ay kung magkakaroon po ng paradigm shift from chemical processes to biological processes usage, how can we use spectrophotometry, specifically yung AAS and also UVVs po, to usher in innovation and conservation at the same time? Ayun.
Ayan, so thank you for your question. Kaso ang problem kasi natin dyan, medyo malaki ang difference ng physical chemistry sa biological chemistry. So there are some biological aspects na pwede nating ma-determine na gumagamit na tayo ng mga physical chemistry like yung na-mention ko kanina. Yung mga bacteriological count, pwede na siyang ma-analyze through UVVs, ganyan. So, however, minsan hindi siya vice versa. So, yung mga elemental analysis, parang mahirap siyang i-convert into biological. Kasi medyo, si AAS kasi ang ginagamit niyan is more on metals. So, mahirap siyang i-convert into biological one. Kasi, of course, I don't know kung paano yung reaction niya. Mostly kasi ang metals, chelation ang nangyayari or magbabind siya. So I don't think yung transposition from from chemistry to biological, medyo parang mahirap siyang i-compare, medyo mahirap siyang i-transition to that. But what we can do, or kung gusto mo talaga is yung advancement na tinatawag, is the advancement from detection of your metals ng AAS into multiple metals siguro using AAS. So I think, sige, share ko na rin sa inyo. We have our future products na kung saan meron na kaming, kumbaga parang i-release na products na kaya niya, AAS din siya, na kaya niya mag-detect ng multiple analysis. So para na rin siyang ICT pero AAS siya. So multiple analysis siya ng metals, ganyan. So however, with just one click. So that's the advancement. Pero yung ito-turn out mo siya into biological, parang as of now, mahihirapan tayo. Unless, on the other hand, biological to chemical. Kasi, ayun, mas madali. Mostly ng mga biological testing namin dito, nako-convert namin siya into chemical analysis. Especially yung sa micro namin. So yun, kaya namin i-determine yung mga E. coli, using chemical analysis, mga ganun. And also, for the biological samples, nade-determine din naman namin yung mga elemental content nila. Pero yung vice versa, parang so far, wala pa tayong method for that because magkalayo sila or different scopes sila ng science. Yes.
Thank you po, ma'am.
Okay.
For our next question po, it will be our pre-prepared question. Have there been recent developments or improvements in the instrumentation of modern analytical chemistry tools that have expanded its capabilities or increased its versatility? Could you please provide studies where these tools have delivered groundbreaking insights in either research or industry applications po?
Thank you. Actually, madami. Madami talaga. As in, katulad nung nalatag ko sa inyo kanina, yung difference between modern and classical methods. So, lahat ng mga modern analysis natin, dumaan yan sa classical method. And I think all of those are groundbreaking insights. So, first, siguro ngayon, to be exact, ang recent namin is yung biological oxygen demand, which is na-discuss ko kanina, di ba? So recently, ang ginagawa lang naming method is titration method lang. So medyo matrabaho siya, maraming shaking na ginagawa and such. But recently, na-approve na ni EMB yung methods na kung saan nakakagamit na kami ng BOD meter para lang siyang electrode na kung saan ipapasok lang namin doon yung ipapasok lang namin yung electrode sa bottle ng BOD and then makukuha na namin yung measurement ng dissolved oxygen. So though I think as of now, yung isa yung one of the groundbreaking discovery. And pangalawa, of course, yung detection ng ating heavy metals. Dati kasi paisa-isa lang yan, hindi kaya siya ng sabay-sabay. But now, we have our inductively coupled plasma optical emission spectrophotometers and mass specs para ma-determine natin ng sabay-sabay yung mga elemental compositions ng ating mga solutions, especially those that are hazardous. So yun, ano pa ba? Actually, marami talaga eh. And also, the automation of our titrators, na dati isa-isa or kanya-kanya kailangan pa natin gumamit ng mga indicators. But now we have our auto titrators na hindi na natin kailangan gumamit ng indicators, less waste, and with just one click, hindi na kayo mag-iikot-ikot, may sarili na siyang steer bar. So hindi na kayo magaganon-ganon ng e-flask. So ayun. Marami din talagang mga analysis na na-automate na ngayon na dati hirap na hirap pa yung mga tao. And also pala sa AES and sa UV spectrophotometer, dati pa isa-isa yung analysis din. But now we have our auto samplers that can cater up to 120 samples. Yun. So mas madali ang buhay, lalo na pag nasa manufacturing industry ka, iiwanan mo na lang yung samples nyo and then pagbalik mo, na-analyze na lahat. Ganun. So, mas mabilis na siya, mas versatile, mas cost-efficient, and time. Hindi na siya time-consuming. Yan.
Ayan, thank you po, Ms. Aika. Sa mga sagot ni Ms. Aika, talagang mapapansin talaga natin yung grabe na talaga yung pagkaano ng ating technology ngayon, yung pagka-modern. Nagiging mas madali yung ating trabaho, kumbaga. So for this part, again, kukuha po ulit tayo ng questions from our live audience. Gaya kanina, you can guys take this opportunity to ask clarity or questions about specific aspects na interesado kayo. You can raise your hand po for your questions po for Ms. Aika. Anyone? Okay, mukhang nagpo-formulate pa sila ng kanilang mga questions. Mukhang inaano pa na lang kanilang thoughts. Ayan, si Mr. De Rojas. Yes, Mr. De Rojas, you can open your mic.
Good afternoon po. So, ang akin po ay about dun sa usage po ng glass cubed. So, required po ba na yung glass cubed is for visible light lang, then yung quartz naman po is for visible and UV? If yes po, possible po ba na nagkaroon ng instances na nagkaroon ng unintentional interferences yung mga multiple kind of lights na yan? Kunyari po ay yung sa glass cubed, unintentionally po nagamit po natin yung visible light at saka yung yung UV light. So ano po yung possible complication na mangyari dun sa process?
Okay, I got your question. So, ayun, kaya ganon, kasi nga, may mga previous na din na nangyari na, siguro, during sa mga application notes, gumagamit sila, halimbawa, yun nga yung tanong mo, na gumamit sila ng glass cuvette, but yung wavelength nila is for UV region. And theoretically, alam natin na ang glass ay absorbing siya ng UV light, of course. So, kung pupunta ka kung mag-UV vis ka, tapos ang i-run mo na wavelength is under UV region, and then gumamit ka ng glass cuvette, ang mangyayari, mag-a-add up po, kasi absorbing siya ng UV light. So parang ina-add up niya lang, mag-a-absorb pa siya ng more UV light, more wavelength, or more light. So magkakaroon ka ng result na false positive. So akala mo yun talaga yung nakukuha mong wavelength, where in fact, hindi talaga. Kasi nga, naturally absorbing ng UV light yung inyong glass cuvette. Kaya importante na alam mo kung ano yung wavelength na kailangan mo and ano yung cuvette na gagamitin mo. Magkakaroon ng spectral interferences.
Ayan. Thank you po ulit, Ms. Aika. For our next question naman po is another prepared question. With the evolving green energy technologies that promote ecological protection, enhancing the system of analytical techniques using modern tools demands considerable efforts from individuals and widespread utilization of resources from our environment. How can modern analytical tools be strategically employed to optimize resource allocation, mitigate environmental impact, and ensure the long-term viability of its sustainability practices?
Ayun. So parang nasagot ko na din to kanina, no? Parang kanina ko pa din kasi pinopromote yung greener chemistry. Pero sige, i-ano na lang din natin, ilatag na lang din natin. So as you can see, most of our modern analytical equipment, direct analysis sila. So when we say direct, ilalagay mo yung sample mo, isisip niya, tapos siya na yung bahala na magpasok dun sa instrument, maglabas, and such. So by that process, mas less yung interaction ng tao dun sa solution mo. So mas less hazardous, una, sa atin, sa interaction with us. Syempre, mga toxics yan. Pangalawa, recently, ang mga modern analytical instrument, they are dealing with minute volume. So, maliliit na yung ginagamit nila. Like, for example, sa UVVs, 3 ml lang yon yung ilalagay mo sa cuvette. Sa AAS, hindi ka aabot ng 2 ml per sip. Sa ICP, around mga ganun lang din, mga microliters lang din yung dinideal with mo. So, imagine ninyo yung technology, yung yung na-improve nilang technology na kung saan with just small volume of your samples, ma-analyze na nila yun. Bakit kailangan mas maliliit? Because yung waste para mas maonti lang din. Kasi 'di ba, yung classical methods natin, for example, titration, kailangan mo agad ng 50 to 100 ml. I-compare mo yun dun sa mga modern equipment natin na ang ginagamit ng is 2 ml or less. And then, for example, yung mga gravimetric analysis natin na kailangan natin mga 100 ml, ganyan. So, yung waste mo, mas malalaki. Paano kung yung water mo na yun or yung sample mo na yun is toxic? So, ayun, in that sense, mas mababa yung waste mo. So, mas less yung resources mo. Kasi yung mga waste natin na to, bakit kanina ko pa siya binabanggit? Because yung mga waste na nag-generate per laboratory, hinuhold din po yan, kinokollect din yan, and then tinitreat din yan, and sobrang mahal niyan. So, hindi sila magko-collect ng halimbawa, per isang ganun lang, isang litro, hindi. By tons sila nagko-collect. So, tons, ganun yung collection nila, and umaabot yan ng mga hundreds of thousands, ganyan. So, hindi lang siya basta-basta. So, in terms of resources, kapag mas maliliit yung dinideal natin ng sample, mas maliit yung volume na i-aano natin, itatapon natin at i-treat. And environmental impact, of course, kanino bababagsak yung mga treatments natin na yan? Kay Mother Earth ulit. So, sa mga water bodies ulit. So, mas konti ang ilalaglag natin. Ayun, mas maganda. And long-term viability and sustainability naman, sa ganito naman, yung mga equipment natin, hindi designed sila in such a way na hindi yearly papalitan. Kumbaga parang ganun. As much as possible, meron yung mga warranty. So, together with the service engineers ng mga suppliers nila, as long as kayang ayusin niyan para mas sustainable yung analysis natin and mas hindi tayo patapon ng equipment or pabili ng panibagong equipment. Yeah. So I think with that, strategically, mas maganda na talaga yung ano ngayon. Kasi ayang mga company na yan, matatalino yan, hindi yan bibili ng mga sirain. Kasi of course, cost magiging ano yan, dagdag sa cost mo taon-taon. So kapag napatunayan nila na yung isang product, mabilis masira, hindi na yan mabibili sa'yo. So usually yung mga analytical equipment natin, patibayan talaga sila. And meron nga tayong mga kasi most ng mga gamit namin dito sa lab is Hitachi. And as simula nung natayo yung lab, hindi pa namin napapalitan, ganyan. And we also have customers na gusto na talaga nilang palitan, pero gumagana pa rin kahit mukha ng Jurassic. Ganun. So sustainable din talaga itong mga equipment na na-develop ng ating mga scientists. Yeah.
Ayan, thank you po ulit, Ms. Aika. Again po, for this part, do we have any question po from our audience? You can raise your hands po. You can raise your hand po using the raise hand feature po in our virtual platform. Ayan po, Ms. Estrella. You can open your mic po.
Good afternoon po, ma'am. Question lang po. Na-mention niyo po a while ago na UVVs can be applied po or yung application niya po is pwede pong pang ano po ng DNA, RNA, pharmaceutical, bacterial. Aside po from those, meron pa po ba siyang other application in the medicinal field po? Kasi po last time, nung nag-SIP po ako sa UP, pinagamit po kami ng UVVs. Tapos meron pong parahong medicine group of students po na may pina-UVVs po. Na-curious lang po ako kung may other application po siya aside po for pharmaceutical po. Thank you po.
Hi, thank you, Mary. Yes, actually, anything that absorbs light, anything na may kulay or may capability to absorb light, magkaroon ng spectra, kaya natin i-analyze in UVs. So one example of this is during my undergraduate studies sa UPLB, isang experiment namin from Biochem is parang enzyme activity. Kinetic study siya, enzyme activity, I forgot the name of the enzyme. Nakalimutan ko na, sobrang dami kasi ng enzyme and medyo matagal-tagal na din siya. Pero yun, enzyme activity siya, so nadidetermine niya yung kinetics nun. So kaya din yun sa UVVs natin. And marami pang ibang medicinal applications, hindi lang RNA. Kasi yung DNA and RNA, parang specific feature lang siya ng ating UVVs. But actually, marami pang iba. And hindi natin ililimit sa UVVs, no? Meron tayong tinatawag na mga spectrophotometers. Ito ay mga general naman. Sa mga medical, medtech, mga ganun, na practitioners, meron silang mga specific spectrophotometers na ginagamit for blood counts. So, yung mga, di ba, kinukuhanan tayo ng dugo, mga ganon. Meron silang mga tests for that na spectro, ilalagay lang nila doon, madidetermine yung hemoglobin, mga ganon-ganon. So, yun, hindi lang limited for UVVs. Yeah.
Ayan, thank you po. Sana nasagot po ng ating speaker ang inyong mga tanong. Meron pa po bang ibang gustong magtanong for the last time? Ayan po.
Good afternoon po. You have mentioned po kanina that there are students na sinasadya ang nasa labs for their thesis. May napansin po ba kayo na most common studies or recurring thesis topics, and how do you think does this reflect po sa current standing of our society from a scientific perspective?
Ay, ang ganda ng tanong. Actually, yes. Parang ang dami na namin ditong napag-graduate na students, no? But mostly talaga ng mga pinapatest dito, especially pag metal analysis, is yung absorption. Metal absorption. Hindi ko alam kung familiar kayo. Halimbawa, meron silang gagawing synthetic water, tapos ipapa-absorb nila sa something, mga organic matters like yung mga dahon-dahon, mga husk, ganyan. Tapos i-determine nila kung na-absorb ba yung metal content. Tapos i-analyze namin sa AES kung ano yung difference nung initial versus nung na-absorb na. So, sobrang reoccurring nun, since natayo itong nasa labs, parang sobrang dami na talagang nagpapatest ng ganun. And, ano ba? Actually, hindi naman kami masyadong pero we also always na next time you tell your advisor na ganito. Paano ba? Ang hirap kasi. Pero iba-iba kasi sila eh. Minsan nga meron pa na nanghihingi pa sa amin ng computation kung paano nila i-prepare yung mga ganito ganyan. So I think this is actually a wake-up call din sa atin na mas maging innovative tayo with regards to yung ng thesis topic natin. Kasi parang sobrang dami na talagang gumagawa ng ganun. So pwede kayong mag-explore sa different areas. So tanong nyo na lang yung mga thesis advisors ninyo. I think marami naman din silang ideas. And also, actually yun, ito pa isa. Kapag magpapasa sila ng thesis nila, gagawa sila ng certain solutions, sobrang taas ng concentration. Like umaabot ng halimbawa 1,000 ppm. Yung 1,000 ppm na yun, sobrang dangerous na yun para sa kanila at para sa environment natin. So, nagugulat talaga kami na, hey, ba't pinayagan kayo ng thesis advisors nyo na mag-prepare ng ganyan kalaki? Kasi the handling pa lang nun, sobrang dangerous na. Hindi namin sure, parang nakaka-anxiety siya kasi nag-gloves ba sila nung prepare nila yan? Nung wini-weigh ba nila yan, may mask sila kasi baka mamaya nasinghot nila yung mismong solutions nila. So, I suggest na maging mas critical yung judgment natin with regards to doon, and mas maging eager tayo sa mga scientific developments natin. So dapat kapag mga metals, lalo na pag toxic, kasama dun sa 5 most toxic chemicals natin or metals natin, wag lalagpas ng around 10 ppm yung studies ninyo. So enough na siguro yung mga less than 10 ppm para mapatunayan yung presence or absence ng metals sa studies ninyo. Huwag kayong mag-opt sa mas matataas kasi it would risk your body and also the environment din. Yeah.
Thank you po.
No, I think dapat na ano din yun, no? Meron din tayong mga general courses kung paano yung impact sa personal health. Kasi nakakaano din talaga, nakaka-alarm na minsan talaga nagsasubmit sa amin na as in pagbukas mo ng sample, amoy na amoy yung solvent. Ganun. So kawawa naman din kayo kung thesis pa lang, nabawasan na ng years yung life. Di ba? So yun, sana meron din tayong mga programs or courses for that.
Ayun. Thank you po ulit, ma'am. Anyone else po gustong mag-clarify? Yes, Mr. De Rojas.
Hello po ulit. So, ang akin po ay about po dun sa process of double beam and single beam optical system. So, ang napansin ko po kasi ay yung sa double beam, meron po tayong sample cubet at reference cubet. Then for single beam po ay yung sample lang po. So, ano po yung essence po ng pagkakaroon ng reference cubet? Ano po yung advantage niya dun sa single beam? If ever for accuracy po siya, paano po siya nangyayari? Yan po. Thank you.
Ayan. So, pag kasi gumagamit tayo ng mga spectrophotometers, may tinatawag tayong noise. So, umpisa pa lang meron na yung absorbance. So, si reference natin, accountable siya for that noise. And also, may tinatawag tayong blank. So, yung method blank natin, ito is either yung solution mo na ginamit for the diffusion of your sample. So, minsan, yung blank mo pa lang, absorbing species na siya. So, imagine kung meron na siyang na-absorb, tapos, meron na siyang na-absorb initially. So, yung sample mo, meron din siyang na-absorb, di ba? So, hindi mo alam kung yung sample mo, magbibigay ba siya ng accurate result since yung blank na ginamit mo sa kanya is absorbing na siya in the first place. That's why the reference goal is to, parang, to let you know na yung blank mo, meron na siya initially absorbance para makita mo yung difference nila. Para kung may makita kang absorbance dun sa blank mo, isusubtract mo yun siya. Halimbawa, yung blank mo, ang absorbance niya is 0.001, ganyan, 001. So, ang sample mo is 0.005. So, technically, ima-minus mo dapat yun kasi dapat wala talagang measurement yung blank mo, di ba? Kasi blank nga siya. So, ayun, it accounts for the signal-to-noise ratio. So, kaya tayo nagma-minus ng reference natin. So, doon natin makikita kung clear ba yung ating noise. Which is, dapat wala talaga siya. So, yun yung difference nila. So, sa single beam, isa-isa mo siyang i-determine. Read mo yung blank. Tapos, pag may nakita ka, read mo ulit yung sample mo. Pag may nakita ka, pag-minus mo yung dalawang absorbance. Kasi nga, ayaw mo yung noise na yon. Ayaw mo yung absorbance na yon. So, sa double beam naman, so meron ka ng reference, nalagay mo na doon, meron ka ng sample, nalagay mo na din, tapos automatically, ima-minus nyo na yon. So, either ways, kung meron man or wala, na-minus nyo yun dun sa reference mo. So, no need ka na maglagay pa ulit and mag-minus pa ulit. So, rest assured na yung mababasa mong absorbance is just specific for your sample and no signal-to-noise ratio na makaka-affect from other solutions. Yeah.
Thank you po. So, again, for the last time po, do we have any question po from the live audience pa? Ayan, mukhang wala na naman po. So we will push through po sa ating last question, last pre-prepared question. We have for students who are currently enrolled in analytical chemistry courses, what advice would you give them to bridge the gap between theoretical knowledge gained in the classroom and practical applications in real-world scenarios?
Wow, ganda naman tanong. Ayan, so sige, advice, actually, super ganda na broad yung theoretical knowledge mo regarding analytical chemistry. So one example of this is, meron kaming mga OJT students, no, na nagdaan sa pandemic. So theory-wise, maalam talaga sila since galing sila sa mga state U. So, maalam talaga sila, ganyan. But, experimentally or practical-wise, hindi pa nila alam kung paano nila i-analyze yung isang bagay. Pero theory-wise, alam nila. Theoretically, alam nila. So, ang kagandahan nito, kapag theoretically, alam mo, konting turo na lang sa'yo ng application, matututunan mo kaagad siya. So, madali siyang matutunan, ganyan. So, ang sinasabi ko dito is, mas maganda na alam nyo din siya theoretically para pag in-apply nyo siya, konting practice na lang, makukuha nyo na siya. But I'm not saying na dapat hindi nyo din siya i-practice, no? Kasi baliwala lang naman yung theoretical knowledge nyo if it would not be applied to the real world. Ayun. So, minsan sa industry, lalo na dito sa ating lalo na sa scientific nature natin, no? Yung expertise sa ating job, hindi siya makukuha ng weeks, months. Makukuha mo siya by years. So years of experience, years of practical application. And yung theory na yan, makukuha nyo kasi yan during your formative years. Ngayon, during your college, kasi based on experience, yan, ganyan. So yung theory, yung knowledge na nakuha ko from my previous studies, ganyan, yun talaga yung foundation mo. Pero yung expertise mo sa career mo, yun ay makukuha mo na kapag nasa work ka na talaga. Kapag napapractice mo na siya, na every year na dadagdagan yung experience mo, by experience ka talaga mahahasa. Pero hindi ka mahahasa kung wala ka din knowledge prior. So, if I were you, huwag kayong ma-boring, huwag kayong sana maging eager lang kayo na aralin sila. Kasi sooner or later, pag-graduate ninyo, marirealize nyo, kaya pala ganito yung mga pinag-aralan namin kasi para dito pala sa application na to. And mamamangha na lang din kayo na, ito pala yung application niya. Ganon. Kung mapupunta kayo sa tamang company, which is sana, pupunta kayo kasi makikita nyo na, dati pinag-aaralan lang namin ito theoretically, tapos ngayon, na-apply ko na siya. Lalo na ako kasi, di ba, sa UP, medyo low budget, ganyan. Minsan yung mga modern analytical equipment ay museum. Parang i-imagine nyo na lang. Imagination, so ipapakita lang ng prof, ganyan. But theory-wise, we are super fed, super tinuturo sa amin yan, ganyan. That's why when we go outside of the school, kapag nasa mismong work ka na, matutuwa ka na, ito pala yung tinuturo sa amin dati. And then you're gonna know how to practically apply it. Yun. So, may bang question? Advice. Ayun. Just, akala nyo lang walang sense yung mga pinapaderive sa inyo. Yung mga equations na yan, yung mga diniderive nyo. Akala nyo lang, but someday it will make sense. Yun.
Ayan, thank you so much po for Ms. Aika Benaventura. That's it for our open forum. We were able to delve into the complexities surrounding modern analytical tools and had an incredible exchange of perspective, showcasing the depth and diversity of opinions on this critical subject.
And now, moving ahead, it's time to honor and acknowledge the contribution of our dearest esteemed speaker. I would like to invite again Ms. Kimberly Claire B. Brodet, the overall head of Calibrate 2023, to present our speaker with a certificate of appreciation for her valuable insights.
To award this certificate of appreciation, this certificate of appreciation is hereby given to Angelica P. Buenaventura for her invaluable contribution